Hello, this is Neil Neslucin, Vice President of Sales and Marketing at Multify. Thanks so much for viewing our webinar today, Cost-Effective 100 Gig Metro DWDM Solutions. Joining me on the call is Dr. Rangchen Yu, Vice President of Business Development at Uplink. The premise of this webinar is that the Metro WDM market is growing, and growing perhaps at a greater rate than other areas of the wide area network. There are many game-changing bandwidth drivers that are well known in the industry, cloud services, both at the corporate but also at the consumer level, video services, people wanting to use Hulu or Netflix to watch whatever video when they want and not wait for the broadcast on cable TV. And mobility services, people using things like smartphones and tablets, and of course still PCs, to do all kinds of work, not just make telephone calls and text people. These bandwidth drivers that you saw on the previous page are fundamentally changing the way that the internet gets built out or rebuilt. Today, about 50% of all traffic gets terminated in the metro. But we see that increasing to as high as 75% of all internet traffic being terminated in the metro, specifically because of these kinds of applications. And the key there is the applications and the data that they access needs to be relatively close to the consumers in order to protect the user experience. Now, what you see on the right-hand side is a map of the San Francisco Bay Area, and what we've drawn there is sort of a representation of a massive distributed data center around San Francisco Bay. The key is not only the size of each individual data center, but the capacity of or the bandwidth of the optical connections between them. Now to talk about the next few pages is Dr. Rangchen Yu from Uplink.
Now let's discuss metro transport requirements. First of all, increased bandwidth demand is greatly drive the data rates upgrades from 10G to 100G. Secondly, in the metro environment, there's relatively more abundant deployed fiber versus long haul. Therefore, cost trade-off between upgrade speed versus use of more fiber. In general, lower cost per gigabit per second is a requirement when upgrade to higher bandwidth technology. Let's talk about challenges of 100G Metro DWDM. Optical fiber chromatic dispersion is limiting severely on a single channel OOK transmission distance. For example, dispersion penalty goals like data rate squared. For example, 40 km at 10 gigabit per second is equivalent to 6 km at 25 gigabit per second and less than 0.5 km at 100 gigabit per second. On the other hand, long-haul DWDM solutions with DP QPSK is complex, high power dissipation, and high cost for metro. At this point, the cost is significantly higher than even 10 times of 10G DWDM.
In order to achieve that inexpensive 100 gig Metro DWDM module, we propose that a module be built using direct detect methods and an enabling DSP such as MLSE. What we're going to show here is an A to D front end on the receiver chip inside the module, which will digitize the receiver output and then follow that up with an MLSE based DSP, which is going to look at the bits in a stream and correct for the intersymbol interference realized in the stream. Now, when you combine that with industry standard forward error correction, you can achieve between 300 and 500 kilometers for metro transport needs. Now all that functionality is realized inside the Multify MP1100Q, MP1101Q 100 gig direct detect chipset solution. The DMUX is a fully integrated A to D with DSP running the MLSE processor and of course providing full gearbox functionality. The MUX is a full transmit gearbox MUX. It provides low power dissipation, supporting standard CFP applications. The architecture is absolutely scalable to future 400 gig applications, and most importantly, we allow the realization of a low-cost module based on mature 10 gig optoelectronics. 40 to 80 kilometer reach can be realized, or combined with standard FEC, you can reach hundreds of kilometers in a typical WDM network.
Now let's discuss key attributes of uplink 100G Metro DWDM CFP. The CFP is designed with MSA compliant form factor and electrical interface. 10G DWDM EML or tunable transmitter and 10G receivers are used for lowest cost. Enhanced fiber chromatic dispersion, PMD tolerance, and modest OSNR to support 300 to 500 km DWDM transmission applications. APD receiver option to support brownfield deployment with mix of 10G DWDM and compatible with ROADM. Let's discuss 100G DWDM MLC CFP value proposition. On a cost per gigabit per second basis, 100G DWDM MLC CFP starting cost is much lower than 10G DWDM. Over time, with volume ramp-ups and further optoelectronic integration, the cost per gigabit per second will be further reduced. Now let's discuss 4x28G MLC DWDM CFP applications. First application is for inter-data center connection at 100G to 1 terabit per second at distance up to 100 km without mid-stage amplifications. Second application is for multi-span Metro DWDM connections with transmission distance up to 500 km. In conclusion, 4x28G direct detection with MLC digital signal processing is a key enabler for cost and power efficient 100G DWDM solutions for the metro and data center markets. Seamless integration with existing 10G DWDM networks with low cutbacks and outbacks is a key attribute. And there's a further potential for speed upgrades for higher speed to 200G and 400G.
Thanks, Frank Chen, and thank you all for listening to the webinar today. You see our contact information there on the screen. We appreciate your time. We look forward to speaking with you soon.